Welcome back to the channel. Today we are starting with our introductory lecture for our AlgoChief's DSA course. Today we will be teaching you all the advantages, uses of all the data structures which we will need in our DSA or CP journey. Each of our data structures have a visualizer, a syntax chart and a complexity chart. So you can head to algochief.com and use these visualizers to understand the topic better. So our topics for this video are arrays, list, queues, priority queues, Deque, set and maps. There are two major structures which you may not see in this list. One is stacks, one is linked list. Linked list is not there because to access any value of a linked list, we need to traverse through the entire list. Hence, linked list is very unoptimal in DSA or CP. Hence, we always avoid using it. For stacks, we have better structures like dequeues, which combines the functions of stacks and queue. Hence, it is not needed, and there are hardly any questions which use stack as an answer. Okay, so these are our main 7 structures which we will need in our journey, and we will learn them today. Starting with arrays. Array is the most basic data structure which is used as a static list, which means at declaration you define its size, and then throughout the entire program you cannot change its size. If you have to change its size, then basically the array is redeclared. Okay, which means you cannot insert or delete any values. Once you declare an array, the size stays there until you declare the same array to another size. Okay, so the first step is declaring the size. Once we declare, we get a blank array. After that, we can assign any index to whatever value you want in O of 1 complexity. The declaration part takes O of n complexity, where n is the size of the array, whereas all assigned values will work in O of 1 complexity. Okay, the syntax for array is simple. In Java, you need to declare an array object and you can access the ith index using AOY. In C++, you can declare an array like this, specifying the size. Specifying the size in arrays is compulsory. Okay. To assign the value, you can use again AOY. Okay. For the complexity, declaration takes O of n complexity, whereas accessing a value at the ith index or editing it takes O of 1 complexity. Hence, this array is a good basic structure if you want to maintain a list whose size is fixed and all you want to do is edit the values. Okay. Moving on to lists. List is a basic data structure whose size may or may not be constant. Here we are mainly talking about dynamic lists. Here in lists you can append and erase elements from any index or position you want in the lists, and you can access the value of any ith index anytime. Okay, so you can append any values. You can also erase any index from the list. You can assign the value to any index you want, and you can insert values at any specified index you want. Okay, so for the complexity, if you want to add an element to the last or to the back of the list, that is O of 1 complexity. If you want to remove an element from the back of the list, that is also O of 1 complexity. But if you want to insert or erase an element from any other index, the worst case for that is O of n. Because if you are inserting at suppose the first index, then it needs to adjust all the indexes of the rest of the elements of the list. Therefore, this takes O of n complexity at worst case. Same for erase. If I am erasing some random index from between, it needs to shift all the values ahead to its new index, and that at worst case takes O of n. Therefore, a list is a great structure to insert or delete at the back when you have variable data size. But if you want to insert or erase from any index or any value, then a regular list is not optimal. We have many advanced data structures which do this job in over 1 or log n. Okay. In Java, we use ArrayList as a dynamic list. In C++, we use vector mostly. Okay. To add an element to the last position, you basically use .add in Java. If you want to add an element to the ith index, then you need to specify the index in the add function. Okay. To remove the ith index, you can specify the index in the .remove function. To set a value at the ith index to any value you want, then you use .set function, and this .set function takes of 1 complexity, whereas other add and remove functions may take O of n at a worst case. This takes O of 1 complexity. So same as a regular array, you can assign the value in O of 1 complexity. Okay. Similarly, in C++, you use pushback to push an element to the last position. If you want to insert it at any index, then you will need to refer to the iterator as dot begin and add whatever index you want to it to add an element to the ith index. Okay, the complexities of Java and C++ are both same. Erase and insert will take O of n at max. Pushback will take O of 1 complexity. Set and get uses O of 1 complexity. Okay, so this is the complexity chart. If you want to just use the array list as a regular list whose size is variable and you are inserting at, at, at the back, then it is a good structure to use with good time complexity. If you want to insert or delete from any index from between, you have better options to use than this list. Moving on to queue. Queue is a linear data structure that follows first in, first out principle. That means the element which is inserted first will be the one to be removed first. Okay, this is just like a basic list. Whatever you insert goes at the back of the queue, and at all times you can only access the first element of the queue by using peek, or you can remove the first element by doing the pop function. Okay, now this queue is often used when we want efficient deletion of values from the first index of our list. If we delete values from the first index of the list, it takes O of n complexity because it needs to shift all the elements one index previous. Okay, but for queue, if you want to delete the first element, that takes O of 1 complexity. Therefore, in questions where you want to remove the top element, or you are continuously deleting the first value of a list, a queue structure is often preferred. Okay. Now in Java, the underlying structure of a queue is a linked list. Okay. To add a value, it's simple. Just put q.add_value. This takes off one complexity to add the value to the back of the queue. To see what is the first element, you can use q.peek, and to remove the first element from the queue, you can use q.poll. In C++, the functions are push to add an element, dot front to look at what is the first element, and dot pop to remove the first element. Insertion at the back of the queue is of one complexity. Deletion from the front of the queue is also of one complexity. Okay, hence this data structure is often used when you want to delete elements from the front in an efficient manner. Okay, moving on to priority queue. Priority queue is a data structure which is very similar to a regular queue, but each element has an associated priority. Okay, means the elements inside of the queue are automatically sorted based on the comparator you specify. Okay, let's think of a basic priority queue that sorts element based on its increasing order. So in this queue, no matter in which order you enqueue the elements, when you iterate the queue or you want to see the first element, it will always be in a sorted order. Okay, so advantages of the priority queue: no matter however you insert or you remove, whenever you look at the queue, it is always sorted. Hence, you don't need to sort the list again and again. In a regular list, you had to sort the list after you insert any value if you want to maintain a sorted order, and that takes n log n complexity to sort it again. But whenever you insert a single element in priority queue, it automatically gets placed in its sorted position, and this takes only log n complexity. Hence, it is much better in maintaining sorted order. The disadvantage is that priority queue does not store indexes, which means at any time you can only access the top element or the first element. You cannot access any other element from the queue. Okay. Now for the syntax for Java, you, this is how you declare a queue. Okay. If you want to add an element, you use dot add or dot offer. Okay. This will automatically place the value in its sorted position, and this takes log n complexity. Q.peek is used to see which is the top element of the queue. This takes over one complexity. And queue of poll removes the first element from the queue. Like this, it goes away from the queue. Okay. This also takes over one complexity. Okay. Whereas in C++, to add an element, you use dot push function. This also takes log n complexity. To obtain the first element, you use dot top, and to pop the first element out, you use dot pop. Okay. In Java, a regular priority queue is sorted in ascending order, whereas in C++, a regular priority queue is sorted in descending order. Okay. You can specify your own comparator and sort the priority queue based on whatever tick- whatever tick- requirement you need in your question. Okay, insertion complexity is log n, and the only place you can delete is from the front, which is over 1 complexity. Okay, moving on to DQ. DQ is a double-ended queue which allows insertion and deletion of elements from both the front and back. Hence, it combines the features of stacks and queues, and it is better than a regular queue or a regular stack. The only disadvantage of a DQ is that you cannot access any element using the ith index, and the elements are not sorted. You can only access the first and last element. So, if you are performing operation in which you need regular access of the start and end values efficiently, like using a palindrome, or you are continuously performing operations from the start and at the end. So, DQ is an efficient data structure to perform those operations. Okay, at first it is like a regular queue, and then you can also append elements at the front. You can get the values of the first element and the last element. You can also remove the first element or remove the last element. Hence, DQ is often used more than regular stacks or regular queues. Okay, here there's a mistake. It should be array DQ. Okay, for the Java syntax, the declaration is as an array DQ. Okay, to add an element to the back, it is add last. To the front, it is add first. To obtain the first element, it is peek first. To obtain the last element, peek last. To pop the first element out, it is poll first. To pop the last element out, it is poll last. Okay, similarly for C++, you first declare an empty DQ, then you can push back, push front, then dot front and dot back to obtain the front and last element, and pop front or pop back. Okay, all of these operations are performed in an constant over one time complexity. Hence, for doing any operations at the start and at the end continuously, ArrayDQ is a very efficient and optimal option for those types of conditions. Moving on to set. Set is a data structure which gives us efficient insertion and removal operations. It has two types, unordered set and ordered set. In unordered set, all the elements are randomly stored in the memory. They are stored as hash values, and it gives constant time complexity for removal, insertion and searching. For ordered set, all of the elements are stored as sorted list. Means not as a list, but all of the elements in the set are sorted. It is stored as a red black tree, and this gives us log time complexity for removal, insertion and searching operations. Ordered set gives an advantage over priority queue, since priority queue can only access the first value of the queue, but a set can access both first and last values of a set, and it can also find the strictly greater, strictly lesser, or upper or lower bounds of values. It can also search a value in log time complexity, which priority queue cannot. The only disadvantage of a regular set is that it cannot store duplicates. An advanced version of a set exists called as multiset, which has all of these operations plus it can store duplicates. But the time complexity for that is a bit slower due to the memory usage, and we can implement a multiset using a map, which we will see next. Okay, and multiset is only available in C++, not in Java. Okay, so this is a visualization of a sorted set, means ordered set. Okay, you enter any values. This all happens in log n complexity. You can erase any value for any value you want from the start and middle anywhere. All of those happens in log n complexity. This upper key finds the least key which is strictly greater than the search key. If we put 2, 4 and 6 both are strictly greater than 2, but the least from them is 4. For lower key, it finds the greatest key that is less than, strictly less than the values. If we check for 8, 4 and 6 both are strictly less, but the greatest among this is 6. So lower key will give you 6, and it also gives you the first values and last values of your set. Okay, now for the syntax. In Java, unordered set is stored as a hash set, ordered set is stored as a tree set. There's add operation, remove operation, contains operation. Each of them is done in O(1) or log n based on ordered and unordered set. Now these below functions are only for ordered set. You can find the first value, last value, higher key, lower key. Each of these operations are done in log n complexity. For C++, you have an unordered set and a regular set. Insert operations, erase operations, count operations. These are either O of 1 or log n based on unordered and ordered set. And same as Java, you can find the first, last, upper and lower bounds by using the inbuilt binary search functions. st.begin will give you the first value, rbegin will give you the last value, upper bound will give you strictly greater key, and lower bound with a decrement gives you a strictly lower key. Okay, insertion, deletion and search is over 1 or log n based on ordered set or unordered set, whereas upper lower bounds, first last key, all of those are log n complexity and only available in ordered sets. So set is a very good data structure for efficient insertion, removal, searching. The only disadvantage is duplicates, and this can be solved by using a map. Okay, which we will learn in the next topic. Moving on to map. Map is also a structure which has all the functions of a set. The only difference is that it stores elements as a key value pair. Now, even though a map cannot store duplicates, you can use this value to your advantage by putting the value equal to some count or a list, and and anyway you can implement this value to be your counter for to handle the duplicates value. Okay, so all of the functions of map are same as set. The only difference is it stores values in a key value pair. Okay, the visualization is also same as set, only it contains values in a key value pair. Okay, the values in an ordered map are always sorted by your key. You cannot sort your values in a map by your values. It is always sorted by your key value, never by value. Now if a key already exists and you try to insert it again with a different value, then that value gets overwritten by the key you just inserted. These functions are same as your set. It finds your first and last key, upper and lower bound key, and you erase and insert by key, not by value. Okay? For Java, unordered map is stored as a hash map. Ordered map is stored as a tree map. To add a key value pair, you use key comma value with put function. Then the same remove function, get function to get a value for a key, then contains function. All of these are over 1 or log n based on unordered or ordered map. Okay, now these functions are only for ordered map. First key, last key, higher key or lower key. Same as set. Okay, this should be ordered map. Okay, for C++, a regular map is an ordered map. Okay, to add a key to the map, this is how you add it. Map of key equals to value. To erase a key, you, you can use dot erase. To get any value from the key, you can use mp of key again. Count will find whether the key exists or not. All of these functions are over 1 or over log n based on unordered and ordered map. Okay, and the same functions just as your set. Now this auto key will be as type iterator. So since map is a key value pair, this will give you a pair value, and so to get the key you will need to use dot first, since it is the first value of a pair. And if you want the value, you you can use asterisk key dot second to get this value. Okay, now the complexity for insertion, deletion and search is over 1 or log n based on unordered set or unordered map or ordered map. Okay, now the only disadvantage of unordered map is that it cannot be sorted, and the most important thing is, once the size of your structure increases and you get values of various ranges, then the problem is that it stores values by hash tables, which means there are chances of collisions. And if the value of collision is very high, the worst case complexity for an unordered map could become O of n instead of O of 1, and same for set because it is stored under the same principle. But for ordered map, no matter how the size of the data is, it will always be log n, no matter what. Okay, so thank you guys. So thank you guys for watching. Make sure to subscribe and share this video to your friends, and we'll meet in the next lecture.